Alrighty, hello everybody, and welcome back to the channel. Okay, so I went out to space in the space plane, and I observed a couple of things that need to be changed here, and then I think we'll be ready. I'll be ready to really start to explain some things, some more things about space. So what we need is I need to measure this tilt, and I need to measure this tilt. And then, so for that, for the front tilt and the side tilt, so some of these aren't connected, right? 1, 2, and 3. So we can get rid of that one, and that one, and that one, and we can say a dial. So that'll be front tilt, and this will be side tilt. Front tilt. This will be side tilt. Alright, so now what we need to do is the front tilt needs to go there, and the side tilt needs to go there. Now what we need to do is we need to take these thrusters. Alright, so you'll notice that when they thrust, okay, let's save this. Let's just use, I'll just go with this example. Alright. So when the thrusters activate, they don't spray in straight down. They spray on an angle. So if I said 2, oh, you see how it's kind of spraying? I guess it is. All right, never mind. So, all right, never mind. All right, so what we need to do is take these and what do we need to do here? They're inverted. So on the rear of the ship, they go in the opposite direction than the front of the ship. So what I need to do on the rear of the ship is I need to take these ones and I need to copy them, and I need to make a second set. To make the second set. Oh, I didn't rotate these yet, did I? No, I didn't rotate them. So that's not gonna work. Let's try that. Let's try that. Okay, so that's connected. Now we need to connect composite. Alright, let's see. I don't even think I needed to rotate them. I think we just need to. So basically what's happening is that I'm in space, and you can tell the thrusters to hold position. but it still allows for a velocity of like over 100 meters per second, which is fast. So you're still moving really fast through space. So what I'm trying to do now is I'm actually going to try and use the air to yeah. I'm going to try and use the air to slow the ship down. So you see now the front and the rear are now blasting in the same direction. So what I need to do now is make a switch. In here that turns those off and turns those on. So Z negative. So when I press the Z positive, I'll have to figure out what value that is. When I press channel 4, alright, when I press channel 4, I'm assuming this is probably the front and this is probably the rear. Yeah, Z positive and Z negative. So now the Z negative, we don't want that to turn on. So we're going to add an additional switch in here. Oops. And it's going to be an additional composite switch box. And then this is going to be the off value. There we go. And when we press this one here, when we press channel 4, it shouldn't fire. See, there's additional relays. Now I could make a script. Again, we can do the same thing with the code. We can just build a script which does all this for us. And I might end up doing that just because it'll process the numbers smoother than with all the relays and stuff. So, okay, if I press 4, there we go. Now I have to do the same thing for 5. So what is going to happen? What is going to happen is we are going to have an. I wonder if I can even add that on there. Let's see. So for the front and the rear thrusters. So instead of using that as a relay, and we'll need another switch, another composite switch box for here. This can be the off value. For the front. Now, let's see, how can I make this simpler? The on value. So, yeah, I don't think there's a way to I could just have a separate output. I think maybe the best thing to do here is just have a separate output. Yeah, we'll do that. We'll have a separate output. And then that way I don't have to change any of this or recalibrate any of this. And so then what I need to do is I just need to double up. Allow me to explain and it will all make sense, hopefully in a moment. So one set of thrusters is going to allow us to rotate the ship, and then one set of thrusters is going to allow us to stop the ship in a single direction. So I can spin the ship and use the ship's rockets to stop the ship from moving in this direction. But if the ship is moving in this direction, right, I then have to rotate it, and it just seems like it's a lot of work. So if I could, while it's in this position, use the air to slow down this speed, and then use the air to slow down this speed, I'm thinking that's going to be, might be a little more effective. It's just right now, I've got the inputs inverted. So what I want to do is just change that around. And then we'll have like a little button. I'll have a little button. So many, let's see. Then what do I need here? Boy, oh boy, this is some confusing stuff. Okay, so now what we're going to do is inside here, so we need 4 buttons now. We need 4 buttons. We need 1, 2, 3. Actually, we need 6 buttons. Really, really easy. And this is going to be X positive, and this is going to be X negative. So just like the seat, this will be Y positive. This will be Y negative, and this will be Z. And this will be Z negative. All right, so now that we have that set up, they are here. So these inputs come in. Oh, yeah, there. Negative, positive, negative, positive, negative, positive. Okay. All right, let's just reverse that. Okay. So we have our X, Y, and Z. Now, our outputs are just, oh, I don't have an X output on this, do I? Well, I probably do somewhere. Oh, it goes on the front and the rear. There's two types. That's right, there's two types. So I don't know what channel that is. Channel 5. So channel 5 is position stabilization. Okay, so channel 1 and 2 is X positive and X negative. 3 and 4 is Z. I wonder if I'm using... That's probably all I'm using. I doubt that I'm using Y. So just channel 1, 2, 3, and 4. I think that's all we're using. Let's check. Channel 4, channel 5, channel 2, channel 3. Yeah, because channel 5 is position hold. So we're using 1, 2, 3, 4, and then channel 6. Channel 6. Enable rotation stabilization. Oh, interesting. Am I even using that? I guess. Channel 6, but I don't think I have channel 6 set up as rotation stabilization. I think it's in from whatever that channel is in from the seat. Okay, so we got to look at the seat. So Y negative and Y positive, channel 1 and channel 6. Okay, so this is our Y here, and this is channel 1 here, channel 6. Okay, so this must be the wings. Interesting. Interesting. That should be our rotation, which I guess depending on our alignment, but that should be our rotation. That shouldn't be... Alright, so now we need a switch box. Two composite switch boxes. This one, Y positive. This one, Y negative. And we are gonna thrust on channel. Oh, I see. So that's channel 3 and that's channel 4, but we want channel 1 and channel 6. Channel 1 and channel 2. Channel 2. Channel 1, where's 6? Hold on. Start channel 1. This is... So when we activate from the seat, it's giving us channel 3 and 4. What the heck is that? Channel 3 is Z and Z. Oh, because it's going to the wings. So it's rotating to the wings. Gotcha, 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 gotcha. So the wings are our Z. So we want Z positive and Z negative. Right. I don't know. It might even be easier just to let's do this instead. It's going to be easier just to make a new microcontroller, considering because the seat already goes into here. So we'll delete all these. Let's just make another microcontroller. Did I get rid of that? I did, didn't I? Oh, I can't undo it. Oh man. Position hold. My bad. That's an important one. Okay, so let's take a blank microcontroller. What time is it here? It is okay, and then I'm gonna have to get going here soon. All right, so we take a blank microcontroller. What we want to do is we want to have our 4 inputs. 1, 2, 3, 4, 5, 6. Our 6 inputs. 1, 2, 3, 4, 5, and 6. And then we want to have a composite output. All right, and then same thing. Y positive, Y negative, X positive, X negative, Z positive, Z negative. Now, the idea here is that we want all of these thrusters to thrust when these are being pressed, because we're just trying to slow down our linear speed on these axes. I hope that makes sense. All right, then we just need a bunch of switch boxes. 1, 2. Let's see, and then and then we need the composite channel. So let's update this and let's just see what Y is. If there was I don't know if there was a Y. It's just X positive and negative, Z positive and negative. And then we can go body. Body X, body Y, body Z. I wonder if that's what we need to slow us down. Channel 8, 9, and 10, X, Y, and Z. Let's try that. So this can be, let's see, X. There we go. Then this would be channel 8. No, hold on. Start to channel 8. The 8. 7 is positive, 8 is negative. Okay, so channel 7 is positive, channel 8 is negative. Oh, and then, man, that's wrong. Okay, so 7 is positive, 8 is negative. Then 9 is positive. Oh, does it, hold on, does it go to, body Y, body Z. Okay, perfect. So it does go X, Y, Z. So body Y and body Z. There we go. And then that could just go out to the thrusters, just like that. It should be that easy. And then we'll restart the music. And 1, 2, 3, 4, 5, 6. Now we can test out, make sure everything works. Now we need 6 buttons in here. So we can do this actually. Flip switch. Start with number 4. Flip switch. Okay, now this can be channel 7, and this can be channel 8. This can be channel 9, and this could be channel 10, and then this can be X positive, and this can be X negative, and this can be Y positive, and this can be Y negative. And then on this panel here, this will be a flip switch. And this can be a flip switch. And this can be channel 11. And this will be channel 12. 7, 8, 9, 10, yeah, 11, 12. And this should be Z positive and Z negative. Oh, why did I hit the spawn button? Okay, so now in here we need to allow that so this is our X, Y, and this is Z. Now we need these 1, 2, 3, 4, 5, and 6. Get rid of that. We can get rid of these. But it was good. It was kind of needed those to think ahead, and now right then we just changed this 7. I was on the right path originally, I just got confused. 9, 10, 11, and that's 12. Whew, nice. Then what we could do is we could even, yeah, we can still take one of these. We can still have the 20 channels or whatever, 50 channels. And we can do the same thing, right? 7, 8, 9, 10, 11, 12. There we go. Now let's test this out. Let's test it out. This is Z, and this is XY. And now let's make sure it has power. Yeah, they have power. Let's save it. Spawn them in. Now we should just get broad thrust on a single axis, which is what I'm trying to do. Broad thrust on a single axis, because when we're in space, in order to slow down, that's what we need, is we need broad thrust. Now the front Cool. Broad thrust on a single axis. Yes. Okay, so now what we're going to do is let's real quickly go to space and see if this works. And that is going to be the end of this video. Thank you so much for watching. We're getting so close. Because what we're doing now is we are trying to... Let's see. Yeah, we're trying to do a lot of things. So, jet engine speed, 3, systems. Oh, of course, doesn't have anything. If I can get this to work, then what I can do, if I can get this to work, then what I can do is start to launch smaller modules into orbit. And we can get them to hold their position and see how much air they consume, if they're able to hold the position, right, based on weight and all that kind of stuff. So it's really neat. It's really, really neat. Finally, might be able to put something in orbit. Alright. It takes a minute to get going. Right, because we'll go to space, you'll see. I'll turn on position hold. It will slow the ship down. But eventually, my average linear speed will be about 100 meters per second on any given axis, which for me is way too fast. So the position hold will slow you down, but only to a certain point, and then you get to that minimum below that. If you want to slow down beyond that, you have to manually do it. So if this will work, then what I can do is, see, we have the tilt as well. Then what I can do is I can set it up in the code, and I can say, okay, if the linear speed is greater than this, then thrust this way, and then thrust that way, and then eventually we can set it up so that way it automatically is holding itself in space, which is where we're going. That's hopefully going to be in the next video. That's going to be really cool. Right, we'll hold ourselves in 3D. All right. Likewise with the tilt. If I can measure my tilt, that's the Euler angles, of course, because we're going so fast. So I imagine in space, obviously, I imagine there is a little bit of a linear speed to it. But, I mean, that's pretty fast. 100 meters per second is really fast. And to try to dock onto something at that speed is really risky. So if I can slow it down, that's what I'm going to try and do. Where are we at here? Yeah, now the air, see now that we're in space, the air is enough. As you can see, we still have we're still shooting up into space at a fairly decent clip. So, yeah, see now I'm just measuring our rotation till we're flat. There we go. So now I can control our angles digitally, right, with the air. If we happen to tilt too much now, I can just set it up and say, okay, leave us flat. Because we want to be flat in space. If we're like this in space, then we can get up and we can walk around the ship. Now we still have quite a fair amount of, so we want to be Y like this. Try and slow down this here. And you see it is slowing down. So if I turn on the position hold, now we're starting to tilt. So then we need to adjust ourselves. Oh, this is so cool. This is actually really, really cool. There you see we've slowed right down. We've slowed right down. We don't want to quite reverse, but we can set it up. You know, you see, so it just kind of blasts. There we go. Now we might be going slow enough. Yeah, that I can actually get out and walk around without too much of an issue. Obviously we're in space, but I can still walk around the ship now. So I'll be able to expand this a little bit, right? And as you can see, if I have we're kind of rotating a little bit out, but you see how easy it is for me to walk around now? This is really, really cool. And now, oh, we're rotating too much. So then, there we go. And now we're actually going back towards the planet. So what we want to do is, see how we're slowing that down now? Oh, I could do this all day. I'm having a lot of fun. Eventually, that trend is going to reverse. Potentially. I don't think so, though. Oh no, we're pretty close to the atmosphere. So you kind of get the idea here. You kind of get the idea of where we're going. So now what I need to do is I need to see if that's enough to break gravity. Doesn't appear to be working. No. The only way might be to actually have to use the rocket. So what that means is that our minimum size needs to be something about the size of this ship. It has to carry fuel for the rockets, but it also needs to have these RCSs so that way we can maneuver in space. It's not enough. It's not enough for being pulled back into Earth here. Alright, so I'll load the autosave on that one. That was pretty cool, actually. That was pretty cool. So we went up there and we turned around and we flew way back. So basically it tells me that we're a bit too heavy for that. We're a bit too heavy. So it needs work. It needs work. And I need to think more about like lightweightedness, unfortunately. So, in theory, the ship sits like this in space, and we would have to use these rockets to keep it upright. And they'll have to pulse to keep us at a certain position. And then what we need to do is we'll need to have another tilt sensor. And this one will have to go... Oh, it can't go that way. Which way is it facing? Alright, that'll work. So then we can measure, is it tilting backwards, is it tilting forwards? And then we can set up a, so we have to go back to space, take that measurement as well. Right? Because then, so, yeah, I hope this kind of makes sense. So what happens is that the back of the ship faces the planet, and the front of the ship faces the moon in theory. And that's how we have to sit in space. Unless we want to put these thrusters on the bottom and the front, but then we have to calibrate it because as we thrust, it's going to spin this in all different directions, right? So if we just have equal thrust like that, that could work. That could work. And then the air, all the air does. So this main thrust keeps us sitting in space on the y-axis doing this. We're going to be bouncing like this. And then what the air does is it prevents us from spinning this way and spinning that way. And that's pretty much it. So it should hold us in that kind of position. So it's not really ideal. It's not really ideal. But it's kind of all we got at this point in time. So if we're building modules, say like a satellite, we have to think of the same thing. It's going to have to sit in space like this and have one rocket on the back constantly thrusting. And then it's going to need air to keep it, to hold it in position. So that's going to be interesting to see how I need to do that. So the air seems to be okay for pushing us around, but it isn't that great for resisting gravity. That's what I'm getting at here. Anyways, thank you so much for watching, liking, and subscribing, and I'll see you all in the next one.